Hi, I'm Miss Hall, and this is Lesson 81, Independent Events and Dependent Events. We'll begin with the probability of independent events. Two events are independent events when the occurrence of one event does not affect the occurrence of the other event. An example would be rolling two dice. It doesn't matter what the first die is. When you roll the second, it has an equal chance of being 1 through 6. Those are independent events. And for the probability of independent events, two events, A and B, are independent events if and only if the probability that both events occur is the product of the probabilities of the events. So this is what we're going to be doing. If we're looking for the probability of two events occurring and they're independent, we're going to take the probability of the first event times the probability of the second event. Let's do an example. As part of a board game, you need to spin the spinner, which is divided into equal parts. Find the probability that you get a 5 on your first spin and a number greater than 3 on your second spin. So for this example, we're going to say that event A is a 5 on your first spin, and event B, I probably shouldn't put an equal because that's confusing. So event A is getting a 5, and event B is a number greater than 3. A number greater than 3. So the probability of A and B is the probability of A times the probability of B. Stop for a moment. These are independent events because no matter what you spin the first time, does not affect the outcome of what you spin the second time. These are independent events. They do not affect each other. So the probability of A, the probability of landing on a 5, well, there is one space that is a 5 out of 8 total spaces. You have a 1 in 8 chance of spinning a 5 times the probability of a number greater than 3. There are 1, 2, 3, 4, 5 numbers greater than 3. When you multiply those, you get 5 over 64. So the probability of A and B occurring is 5 over 64, which can be written as a decimal, 0.078, which can be written as a percent, 7.8%. Any of those three answers are equivalent. You should be comfortable converting to all three answers. Now, the probability of dependent events. Two events are dependent events when the occurrence of one event does affect the occurrence of another event. A classic example of this is picking something out of a bag and not replacing it. So imagine I have a bag of marbles, 3 are red, 3 are blue. The probability of picking out a red marble, and then I keep that marble out of the bag, and then picking out, say, a blue marble, those are dependent events because I don't replace the red marble. So once the red marble is out, the makeup of the bag is different. Okay, and you'll see an example of this in 4. So the probability of dependent events. If two events, A and B, are dependent events, then the probability that both events occur is the product of the probability that the first event and the conditional probability of the second event given the first event is the product of these. So again, we're multiplying, right? So the events probability of A and then B is the probability of A times the probability of B given that A has happened. So this is the conditional probability. That second one is that B is going to happen given that A happened. Example 4. A bag contains 20 $1 bills. Let me write this. 20 $1 bills and 5 $100 bills. You randomly draw a bill from the bag, set it aside, and then randomly draw another bill from the bag. That's why it's dependent probability, because we don't replace that first bill. So you take the first bill out and set it aside, and then you grab a second. Find the probability that both events A and B will occur. So event A, the first bill is in 100, and then event B, the second bill is in 100. So the probability of A and B is the probability of A times the probability of B given that A happened. The probability of the first bill being 100, well, there's 5 $100 bills out of 25 bills total. Now we don't replace this 100. So now what's left in the bag is 4 $100 bills. Now the probability of picking a second $100 bill, well, there's 4 of them left. And the total number of bills in the bag is now 24. And when we multiply this, we get 20 out of 600. And let me reduce that. Where's a good place for me to put this? I'll put it over here. So the probability of A and B is going to be 1/30. I just reduced 20 over 600, which is the same as 0.033, which is the same as 3.3%.